Okay, let's now begin. We just pick up in case you have questions. By the way, who's the president or representative of the class? Because once we have a recitation, he's the one to call the name because I'm not seeing the chat box. Who's the president of the class?
Yes, hello po.
Okay, so once I ask question, and then you just call a name that you want. So is he or she is the one to answer the question, okay? So
Sige po.
it's an option. If you do not want to call, you have to answer. So we're going to discuss right triangle approach. I don't know if you have already watched the pre-recording video that I made and I shared it to you. So it's about the three approaches of defining the 6 trigonometric functions. We are going to discuss now the first approach, and that is about right triangle approach and of defining trigonometric functions. So, right triangle approach. Let us consider the right triangle ABC with 90 degrees at C. So this is the right triangle. So triangle ABC. Here, opposite to angle A is the side BC, which we are going to denote by OPP, meaning opposite side to angle A. Then adjacent to angle A is the side AC, denoted by ADJ, meaning adjacent side to angle A. And then the side AB, which is opposite to the right angle, that is the hypotenuse or the height. So again here, height means hypotenuse, opt means opposite side to angle A, ADJ means adjacent side to angle A. In this right triangle, we can associate 6 ratios of the sides. So these ratios are called trigonometric ratios. And they are as follows. First, we have opposite over hypotenuse. Second ratio, adjacent over hypotenuse. Third ratio, opposite over adjacent. And then reciprocals of these 3 ratios respectively. So they are hypotenuse over opposite, hypotenuse over adjacent, and adjacent over hypotenuse. Again, these ratios that you can associate with the sides of a right triangle, any right triangle, are called trigonometric ratios. Because of their importance, they are given special names. Each of these ratios is given a special name, defining the 6 trigonometric functions as follows. So we call these 6 trigonometric functions of positive acute angle, these trigonometric ratios. So they are given special names, which we are going to call 6 trigonometric functions of as positive acute angle. So let A be a positive acute angle of the right triangle where C is 90 degrees as shown in figure 1. In right triangle approach, this is to remind you that we are going to have trigonometric functions of a positive acute angle, meaning in a right triangle approach, we are limited to dealing with angles that are between 0 and 90 degrees only. So beyond 90 or less than 0 degree, we are not going to consider even 0 degree and 90 degrees for the meantime. But later, once we go to Cartesian plane approach, we can generalize the study of trigonometric functions applied not to just positive acute angle, but to any angle. Okay? But for the meantime, it's limited to positive acute angle. So again, let A be a positive acute angle of the right triangle ABC with C is equal to 90 degrees as shown in figure 1. So this is the figure 1. Then we have the following trigonometric functions of positive acute angle A. Sine of angle A, which is abbreviated sin A, and read of course as sine A, is equal to opposite over hypotenuse. So this first ratio that we have in the list is given a special name, sine of angle A, or abbreviated form, sine A. Next, we have adjacent over hypotenuse. The special name given is cosine of angle A, and it is denoted by cosine A or cos A. Third, we have opposite over adjacent. The special name given to it, tangent of angle A or tan A. And then we have number 4, adjacent over opposite, which is actually just the reciprocal of tangent A. Remember, tangent A, opposite over adjacent. And cotangent of angle A, which is abbreviated cot A and is read cotangent A, is adjacent over opposite. Number 5, we have secant of angle A. So, or abbreviated form, secant of A, or secant A, that is equal to hypotenuse over adjacent, which is the reciprocal of cosine of angle A. And then last, we have cosecant of angle A. That is cosecant A in abbreviated form, and it's the reciprocal of sine of angle A. So again, cosecant of angle A or cosecant A is equal to hypotenuse over opposite. You have to be familiar, and as much as possible, of course, you have to memorize these 6 trigonometric functions, because even we go to another approaches, that is Cartesian plane approach and unit circular approach, giving circular functions, is still same name of functions we're going to use. So the only difference that instead of limiting our angle to positive acute angle, we're going to go beyond 90 degrees or less than 0 degrees, 0 degree, and even quadrantal angles like 0, 90, 180, 270, and 360, and so on, together with their negatives. So we can get their trigonometric functions. So there is a question here. The symbol sine, cosine, tangent, cotangent, secant, and cosecant in themselves have no meanings, standing alone. To have an interpretation, each must be followed by an angle. So sine equals 4 over 5, that's wrong, because there is no angle attached to sine function. So be careful in writing trigonometric function if you have a value. So sine is just the name of the function. So to have a value, you have to attach to it the angle, let's say A. Sine A is equal to 4 over 5. That's correct. This is the proper way of writing trigonometric function value. Sine A, which is equal to a ratio. Okay? So let us have the following example. Find the 6 trigonometric functions of angle A given the right triangle below. So this is the right triangle. Triangle ABC with right angle at C. So opposite to angle A is 7 units, no? So that's the length of BC. Adjacent to angle A, so that is 24 units, which is the side AC. And the side AB, the hypotenuse, is unknown. Since in defining 6 trigonometric functions, guys, we need the 3 ratios, no? So we have to find the value of hypotenuse. So by Pythagorean theorem, we can find that hypotenuse, which is the unknown side in this triangle ABC. So hypotenuse is equal to 7 squared plus 24 squared. Take the square root, getting square root of 625, and that is 25. So we have already completed lengths of the sides of this right triangle. We are now ready to find the trigonometric functions. Starting with sine A, remember our reference angle A, not angle B, because relative to angle B, the opposite is 24, not anymore 7. So depending on the angle, I want 6 trigonometric function of A. Okay, so this acute angle, but also possible to be asked about trigonometric functions of angle B. So let's stick to functions of A. So sine A equals opposite 7 over hypotenuse 25. So 7 over 25. What about cosine A? Cosine A is equal to adjacent over hypotenuse. So getting 24 over 25. Tangent of angle A, that is 7 over 24, meaning opposite over adjacent. Cotangent of angle A, that is adjacent over opposite. Adjacent over opposite, so that is 24 over 7. So which is just the reciprocal of tangent of A. Then we have secant A, that is hypotenuse over adjacent, so 25 over 24. And then notice that secant of A is just the reciprocal of cosine A. And then cosecant of A, that is hypotenuse over opposite, which is just the reciprocal of sine A. So which is sine A is 7 over 25. So we have 25 over 7 for cosecant A. Okay? Do you have any question, guys?
None po ata.
Okay, so let's proceed. So let's have this another example. Find the 6 trigonometric functions of angle B this time. So given the right triangle below. Okay? So we have, wait a minute. It's not writing. Okay. So we have, so again, find the 6 trigonometric functions of angle B. Given this right triangle ABC with right angle at C, acute angle A and B. So, but we are interested with angle B. So opposite to angle B is the side AC. And the other sides are known, 4 and 10, for the side BC and hypotenuse 10. So, and also we are asked to evaluate these expressions, sine B minus cotangent B all over cosine B. And also cosecant squared B multiplied to 1 plus cosine B. So what are the values of these two expressions given the trigonometric functions that you can have from this right triangle? So let's begin. So first we have to solve for the side AC, which is denoted by opposite side to angle B. So again, that is opposite side to angle B. So we now have, oh, it's not, I don't know why it's not working. What's happened? Wait a minute, I think there's a problem with my pen. It's not moving. Move it, move it. What happened to you? It's stuck. Let me check. Yeah, here it goes. Let me check, okay. It's now working. So first we have to solve for opposite side to angle B. So what is the opposite side to angle B? That is hypotenuse squared. Then minus, we have, what is that? 4. So for 4, so squared, no? 4 squared. So 10 squared minus 4 squared, that is equal to 84, no? So 100 minus 16 is 84. So 84 means 4 times 21, square root of 4 is 2. So then remaining inside radical 21. So getting 2 square root of 21 for the opposite side. Now for sine B, we have opposite. So what is opposite? 2 square root of 21. And what about the denominator over hypotenuse? That is equal to 10. So simplifying this, we have square root of 21 over 5. So that's the value of sine of angle B or sine B. Then what about cosine B? What is cosine B? That is opposite or hypotenuse or adjacent. So that is adjacent, right? So adjacent, which is 4, adjacent to angle B over hypotenuse. Simplifying, we have 2 over 5. So next, we have tangent B. Tangent B is equal to what? Opposite, that is square root of 21 over adjacent, which is 4. So simplifying, square root of 21 over 2. What about cotangent B? That is adjacent, which is 4 over opposite to square root of 21. Now, in algebra or in your previous lower math, so if you have a radical in the denominator, we have to get rid of that. So how to rationalize the denominator? We're going to multiply it by square root of 21, both the numerator and denominator. So this is equal to 1. That ratio or that quotient, it will not change the value, it will only change the form. So getting what value? We have 4 over 2, that is 2, and then multiplied by square root of 21. Square root of 21 is square root of 21 when multiplied, so that is 21. So we get 2 square root of 21 over 21, okay? What about secant B? Secant B is hypotenuse, so that is 10 over adjacent to angle B, which is 4. So simplifying, that is 5 over 2. And which is actually just the reciprocal of cosine B. So then we have last cosecant B, that is opposite, so that we have, hypotenuse over opposite to square root of 21. So multiply again by square root of what? Square root of 21 over square root of 21 to rationalize the denominator. So getting, this is 10 divided by 2, that is 5, is square root of 21 over what? 21. Okay, so that's it. Do you have any question, guys? Guys, do you have any question?
None so far po.
Okay, so let's proceed. Let's evaluate this trigonometric expression. So sine B minus cotangent B all over cosine B. All we have to do is to plug in their corresponding values. Sine B is equal to 2 square root of 21 over 10, or that is square root of 21 over 5. Square root of 21 over 5. What about cotangent B? Cotangent B is, where are you? Here. 2 square root of 21. 2 square root of 21 over 21. Denominator, cosine B. Cosine B is 2 over 5. 2 over 5. Then, we are going to simplify this complex fraction. So how to simplify a complex fraction? There are actually 2 ways. You can simplify the numerator into a simple fraction, and then the denominator, no problem with that anymore. So, and then multiply the simplified fraction in the numerator by the reciprocal of the denominator. Or another way is to use the fundamental principle of fractions. According to the fundamental principle of fraction, you can simplify this by multiplying both the numerator and denominator by a number that will make the numerator and denominator free of denominators. So that is by multiplying by the LCD of all the fractions involved. 5 times 21 over 5 times 21. So 5 times 21 multiplied to square root of 21 over 5. 5 is cancelled, so we get 21. Here we get 21 square root of 21. 5 is cancelled. In the second fraction, when multiplied by 5 times 21, 21 is cancelled. So we get what? 2 times 5, 10. So 10, then square root of 21. In the denominator, 5 is cancelled. So 2 times 21, giving 42. Okay? So the numerator contains two similar radicals. Square root of 21 minus 10, ay 21 minus 10, that is 11. Then copy the common radical in the denominator, that is 42. So that's the value of such expression, knowing this information about this triangle. Okay, right triangle ABC. A question, guys. By the way, did you understand radicals? Combining radicals? Okay. A question. Miss President ba? President?
Yes po.
I have a question. You can answer. You can ask your classmate. Okay. Can we add two radicals that have different orders? For instance, let's say, kaya different radicals. For instance, can I add square root of 2 and square root of 3?
Che will answer po.
Huh?
No po, sir.
You cannot add? My question is, can we add
We
square?
can't po.
Huh?
We cannot po.
You cannot?
Bawal i-add, sir. Bawal i-add, sir.
We cannot
Bawal
add po.
Nataranta naman ako sa inyo. Bawal i-add to, children? Are you sure? Square root of
Yes po. They have to be the same po. Tapos ang i-add lang po talaga ay yung
You have the wrong
kasama
concept.
na constant.
We can add square root of 2 and square root of 3. Remember, real
Yes, sir. Pwede po.
can be added. Is square root of 2 a real number? Yes. Is
Sir,
a real number? Yes. Can we add real numbers? Yes. So again, children, can we add square root of 2 and square root of 3? Nano sila na robot sila. We can add. What you mean is that we cannot combine as a single term, but we can add. My goodness,
Yes, sir.
children. Oh, what is the sum? Oh, that's the sum. So we can add, but we cannot combine as a single term. That's what you mean. My question is, can we add? Yes. Did you understand now, children?
Yes, sir.
We can add any real number. Any real numbers can be added, can be multiplied, can be divided except for division. 0. We cannot divide by 0. We can divide two real numbers as long as the denominator is 0. That's the only exemption. We can perform all the operations, addition, subtraction, multiplication, division to any real numbers as long as in division, the denominator is not 0. Is that clear, children? Not head and shoulder, not guard. Is it clear?
Yes! Yes po!
Yes
Okay,
po.
very good. From now on, when you're asked, can we add, let's say, can we add A and B if A and B are real numbers? Yes, we can add. But the sum, A plus B. The sum is just indicated, but we can add. No? We cannot express it as a single letter, yung A plus B, na involve ang A and B. Okay now, guys? I am shocked of your understanding of addition, subtraction, multiplication of dissimilar terms. What am I going to do now with this? I'm going to erase. Siguro your teacher in junior high, you taught you of that, no? That you couldn't add. Okay, so what about the second expression? Cosecant. What is cosecant B? Where are you? Cosecant B. There it goes. 5 is square root of 21 over 21. 5 is square root of 21 over 21. Parang fill in the blanks lang to, no? Yung ginawa ko. Quantity squared. Then, multiply to 1 plus cosine B. What is cosine B? 2 over 5. 2 over 5. Okay, so let's square the first factor. So 5 is square root of 21 over 21. So what is the square of this? So that is 25 over what? Guys? 25 over 21. I slow. Oh, then what about 1 plus 2 over 5? That is 7 over 5. Simplifying 25 over 5, that is 5. 7 over 21, that is 1/3. So 5 over 3. Okay, that's it. A question, guys. Question. No question.
No question po, sir.
Exclamation, guys. Wala
Yeah.
command. Wala rin command. Imperative. No question. Number
Wala
3.
po.
If secant A is equal to 13 over 12, where A is a positive acute angle, find the other trigonometric functions of function values of A. So we are asked of function values of A, knowing one of the trigonometric function value. And that is secant A, which is equal to 13 over 12. Again, A is a positive acute angle. So we know that secant A is what? 13 over 12. Okay, and then we have 13 over 12 secant, that is hypotenuse over what? Over adjacent. So we can arbitrarily assign hypotenuse a value of 13. Adjacent, we can assign arbitrarily a value of 12. When you say arbitrarily, that is not actually permanent. We can even assign to hypotenuse 26. But if you assign to hypotenuse 26, you have to assign to adjacent 24. As long as equal to 13 over 12, you can have the ratio. Then you can have a value for hypotenuse and adjacent. So for such ratio, corresponding ratio. Okay? So we now have opposite. Therefore, is 13 squared minus 12 squared. And that is equal to 169 minus 144, and I think therefore I am 25. So what's the square root? 5. Let's check. Is that correct, guys? 13
Yes,
minus 144. Okay, correct. So sine A is defined as opposite. So that is 5 over hypotenuse. So that is in. What about secant? Sagutin na natin secant. Kabaliktaran lang yan eh. 13 over 5. Cosine A, o reciprocal lang yan ng 13 over 12.
12 over 13.
13. O what about tangent? Tangent is opposite. So that is 5 over adjacent. That is 12. And then cotangent, just opposite. Or reciprocal of 5 over 12, I mean. So that is 12 over 5. Oh, very easy, right? Question number 3.
None, sir.
Giveaway.
Wala na po, sir.
Wala na po. Ganda naman ng boses niya, parang si Kuya Cesar. If tangent theta is equal to 0.7, where theta is a positive acute angle, evaluate the expression sine squared theta plus cotangent theta all over square root of 149 secant theta minus cosecant squared theta. By the way, sine theta when squared, sine, so it means sine squared, ha? We don't square the angle, we square the value of the function. Okay? So that's what it means. The exponent is supposed to be outside the function. So solution. So again, we have what is tangent theta, guys? Anong value ng tangent theta? 0.7, no?
0.7, sir.
But we
Yes.
cannot directly use 0.7 because remember, we define trigonometric functions as ratios. But tangent is not in the form of ratio actually. So can we convert this into a ratio?
Yes, sir.
Yes, po.
7 over 10 po.
So 7
Yes,
over
sir.
10. Okay, and that is opposite over what? Over adjacent, no?
Decent. Yes.
Yes po, sir.
What part of the triangle is missing? Hypotenuse, na? So let's,
Yes, sir.
yes. Question, guys? Is there any question? Because I think I heard a sound. Not a music, but a sound, not really a music. This is 49 plus what? Plus 100. What is 49 plus 100? That is 149. So what's the square root of 149? Baka ilagay nyo 1, 2, 3 ha? Is the square root 1, 2, 3?
No, sir.
Very good. Because there was a time I thought, yun ang HRM, yung magagaling magluto, ang sasarap magluto. Na kapag tinanong mo, ang sagot ay 1, 2, 3. Dahil ang square root daw ng 1 ay 1, square root ng 4 ay 2, square root ng 3 ay ng 3. Pero sasarap magluto. Pero pag math talaga, hirap sila. So, let's now substitute value. Sine. How do we define sine function, guys?
Opposite over hypotenuse, sir.
What is that? Opposite. 7 over square root of 149. Then quantity squared, no? Kasi we square it. Okay? Is that correct?
Yes, sir.
What about cotangent? Call a name, Miss President.
The reciprocal lang po, sir.
Nice voice. Huh?
The reciprocal lang po, sir.
Reciprocal ng ano?
Ano yan? 10
Ng
over.
Tangent po.
This is
10 over 7.
Ayaw
Yes
kong sabihin
po.
kung ano, sinikret pa.
Yes.
Laan tayo, sir.
Sige, square root of 149. What is secant theta?
Hypotenuse over
Hypotenuse.
87.
So, hypotenuse
So it's square root of
over
149 over 10.
square root of 149 over
10.
10.
over 10. Very good. What about cosecant? Then square it, no? Cosecant is
Hypotenuse,
Hypotenuse over
over
opposite. So square root of 149 over 7.
7. So let's square the first term in the numerator. So we have, let's perform the separation. So 49
Over 149.
over 149. Can we cancel 49?
No, sir.
No, sir.
Hindi, ha? Naku, may mga nagka-cancel niyan.
Nako, sir.
Cancel culture talaga, no?
Nako.
This
dapat
is
di talaga
149 times 149 over 10. Is that right? This is
Yes,
149
sir.
over
Yes, sir.
49. Let's simplify using calculator. Let me work on the numerator first. 49 divided by 149 plus 10 divided by 7. It gives us this big number. 1833 over 1043. And then the numerator is 149 divided by 10 minus 149 divided by 49 equals. Then we have 5811 over 490. But we multiply, so we take the reciprocal. So getting
Yes.
what? So what value? We get
490.
multiplied by the reciprocal. 5811. And when simplified, this is multiplied by the 1833 divided by 1043 times 49, 490, sorry, 490 divided by 5811. So the answer, we have 3290 over 2201, 2201 I mean. Paki-check children ha. Approximately children of the Philippines 0.148 14819. Check the value ha. Yan. So
Same
that's
answer
it.
po, sir.
Tama, sir. The good.
Mabuhay, children of the Philippines.
Don't worry. In the future, we will become children of China.
Wag naman, sir.
Ayoko, sir. Local tayo, sir.
The good
Ayoko
moment.
maging imported, sir.
Ay, mali nyo naman, once we become part of China, we will be protected na. Unlike ngayon, many are, buti kayo, you are well up. Ang daming mga Pilipinong really struggling. No, malay mo, tayo ay magkaroon ng magandang buhay. Ma-explore ang yaman ng Pilipinas at ma-share sa atin.
Sir, sorry, may
Vivi.
pins ako.
Viva CCP!
Gul.
And everything now is made of China. So parang next what is your province? Philippines. So let A and B be positive acute angles and ABC positive real numbers. If cosine A is equal to 2AB over the sum of A squared and B squared with A greater than B and cotangent B is equal to 2 square root of AB over A minus B, find and simplify the following expression. So let's copy that. So we have, first, let's work on the function value of sine A. How do we define sine A? Opposite over hypotenuse.
Hypotenuse.
So meaning, we need to know the hypotenuse and the opposite. We already have the hypotenuse from the cosine, no? What we do not have, the opposite. So cosine A, we're given cosine A, and that is equal to square root of. So that is square root of, it's not square root. What's the value?
A squared plus B squared.
Ayan, nilabas ko na yung my beautiful eraser. So what's the value of cosine A? 2A over 2AB all over A squared plus B squared. So this is the adjacent over hypotenuse. Na? So which means we are looking for opposite. To solve for the opposite, that is equal to square root of
A squared plus B squared.
that in the radical. We have square root of hypotenuse, quantity squared. A squared plus B squared, quantity squared. Minus adjacent, that is 2A quantity squared. Okay? Yan. So, opposite therefore is equal to square root of. Let's simplify that radical. So, radicand muna, no? Let's expand. So, we get A squared to the fourth plus what? 2AB squared. Ay, mali. Nawawaw, mali tayo dito. So we have plus 2A squared, B squared. And then plus, what's the next? B to the fourth, no? B to the fourth. And then minus 4A squared, B squared. When simplified further, so let's simplify further. So we have equals, we can combine this second term and last term, no?
Yes.
So, fourth minus 2 squared B squared and plus B to the fourth. And that happens to be what? Anong nangyari dyan? That is equal to, ay, nawala yung radical. So that is equal to what, children?
Quantity A squared minus B
So that
squared
is
to B
equal
squared.
to, that is a perfect square.
Trinomial.
No, the radicand. So the factored form is A squared minus B squared. What's the square root of this, guys? Quantity squared, no? What's the square root?
A squared minus B squared.
Ah? Hala, ano ba yan?
Nawala.
Nawala na. Okay, this is equal to absolute value of A squared minus B squared. No? But since A is greater than B, we are sure that A squared is greater than B squared, right? So we can just write A squared minus B squared. because A squared is always greater than B squared since A is greater than B. Okay? So next, what about tangent? What's that? Cotangent B. So what is cotangent B, children?
A over B. A
So 2 is
adjacent
square
over
root of AB all over A minus B. Yan. So from which it follows that this is what? This is adjacent to what? To B, no? To distinguish, let's say put subscript. Hypotenuse A, adjacent A. This one, adjacent to B over opposite to B. So what we solve is opposite to A. So here, so we now have what? Oh, what is missing? Hypotenuse. Is that correct, children?
Yes, sir.
To B. What is hypotenuse to B? So that is opposite. What is opposite?
A minus B.
Quantity
Squared.
squared minus adjacent. 2 is
Squared AB.
quantity squared. Simplifying, we get hypotenuse to B to angle B is equal to the square root of when expanded, children, A squared minus 2AB plus B squared, and then minus 4 minus ba? I think plus to, no? Kasi hypotenuse yung hinahanap. Yan. So this is plus 4AB. Okay now? So this is when simplified. Call a name.
Si Stanley po.
What is this equal to? The radicand. Square root of what?
Square root of A plus B squared.
A plus B quantity
Squared.
What's the square root?
A plus B.
Absolute value muna. Pero alam natin ang A plus B is what? Ay
A is larger than B.
positive lagi kasi A and B are positive. So this is simply A plus B. It will never be negative. So no problem with that. Okay? So you have to be careful when getting the square root involving radical. Even root is sensitive. You cannot just, let's say you have fourth root of x to the fourth. You cannot simply say x, fourth root of x to the fourth. That is absolute value of x. Unless you know very well what your x is. You can decide. Let's say if x is less than 0, so what is square root of x squared? It is negative x. Because this quantity is always positive. Since we know that x is negative, this is always positive. Okay? So, what comes next? We know already hypotenuse of B. So, of angle relative to angle B. So, we can now find this expression. So, we have A squared plus B squared multiplied to sine of A is equal all over square root of 2 square root of B tangent of what? Of B. Let's substitute the value, guys. What is sine A? A squared plus B squared multiplied to sine A. What is sine A, children? Opposite
Over hypotenuse.
That is A squared over A squared minus B squared over all over what? That is opposite.
A squared plus
So yung ang hanapin nyo kasi A yan, yung opposite sa A.
A plus B.
Over what?
A plus B.
Anong A plus B?
Charot.
Oo, nako, ba't may charot-charot?
Squared plus B squared.
A squared plus B
B squared.
squared. Kasi sa A kayo titingin sa A. Pag sa B, O, then all over 2 is square root of B, then multiplied by tangent. O, what is tangent? Ng relative sa B. That is reciprocal ng cotangent B. So that is A minus B all over 2 is
Sa... Ay, charot na kamay ko.
At ikaw pala, tinanggal mo pala ang saksak. Nalag-out tuloy ako. Are you still there, guys?
Yes,
Yes,
sir.
po.
We got shook.
Lag out ako.
Yes po.
Out of charge. Itong ate ko tinanggal pala yung saksak sa nagluluto siya. Mukha na pang buko. Do you still see the board?
Not yet po, sir.
Wala nang nakashare?
Wala po, sir.
Naku, natanggal pala ang share. Tingnan natin. Share screen. Pag nag out pala, natatanggal ang share. Yan, nawala na din. Nasa na kaya yung isa-share? Ito kaya yun? O, check natin. Share. O, may nakikita na kayo?
Yes po,
Yes
sir.
po.
Anong kulay?
Gran.
Ha? Ano nakikita?
Green po.
Green na, okay na. Yan. Yan ba yung lecture natin?
Opo.
Ano yung last na nakasulat sa ilalim?
2.
2. Let's continue to what is to be written there? What am I going to write? 2 is square root of ano to?
Square root of AB.
A minus, tapang nipis-nipis na ng sulat. Wait a minute ha. I think I need to lalabas uli lang ako saglit ha. I will change the size of the pen. Then Pero wala, may nakashare, guys. O natanggalan,
Meron po.
nakashare pa naman, okay. Kala ko nawawala pag square root of AB. So what's the square root of AB? Square root of AB. Okay. Nipis ng ano? Ng ballpen. Let's now cancel. Anong pwedeng mga i-cancel? A squared plus B squared is cancelled with this na. And then yung B, cancel yung bilang ha. Square root of B, square root of B. Yung 2, cancel din. Oh. So the remaining quantity we have in the numerator, A squared minus B squared. Okay? Times, in the denominator, we multiply by the reciprocal. So it's square root of A over A minus B. Divided by A minus B over square root of A. Yan ay times na to. Kaya take the reciprocal. So that is equal to A squared minus B squared can be further factored into A plus B, A minus B. So we now all over, what is the denominator? So times square root of A to, no? All over A minus B. So this is cancelled. So that A minus B. So we are left with A plus B is square root of A. So that's it. That's the value of the expression. Get it, guys? Guys?
Yes, sir.
Okay, very good. Now let's now have this. Proving. Using the definitions of trigonometric functions of theta, for the right triangle shown, prove by working on one side only that this left side, which is 1 minus tangent squared theta, all over 1 plus tangent squared theta plus what is equal to 2 cosine squared theta. And also, show that cosine theta all over 1 minus tangent theta plus sine theta over 1 minus cotangent theta is equal to sine theta plus cosine theta. As long as all the expressions are defined, so for the given theta, so show that the left is equal to the right. Using this right triangle and the definitions of trigonometric functions. Okay, so let's start working on the left side. So let me copy the left side. So 1 minus tangent squared theta all over 1 minus plus tangent squared theta. And that is equal to, plus pala. Ay, naku. Ang liit kasi ng screen. Next time, bibili ako nung yung cord para sa TV ako nakaharap. Yung malaking TV namin, sasaksa ko tong laptop ko. Ano yun? 55 inches. 65 ba? 55. O di, ang laki ng screen ko, right? Pag hindi ko pa naman nakita yun, ewan ko lang. Equals. So, what is tangent, guys? So, what is tangent? Read it from the triangle. Give me the value of tangent, guys. 1 minus. Oh, what is tangent? Hoy, guys.
Sine over cosine.
Huh? Hindi sine over cosine. You read it from the triangle.
Sir, M over R?
We're going to use definition, not trigonometric identities. What is tangent?
M over R, sir?
M
M
over
over N.
Yan, M over N. So we just copy it in the denominator, no? So we have M over N, quantity, what? Is squared. And that is plus 1. Okay? So this is equal further to, let's simplify further. Magawa muna tayo ng fraction. We multiply both the numerator and denominator by what? by n squared. No? And at the same time, we square this m over n. So 1 minus m squared over n squared all over 1 plus m squared over n squared. So again, what is our multiplier, children, to that? So that we can simplify this complex. We multiply by n squared over n squared. So this fraction n squared over n squared will eliminate the denominators of the numerator and denominator. So then we have plus 1, no? Plus 1. This plus 1. This is equal to, make a fraction. So n squared times 1 is n squared minus m squared, n squared divided by n squared. So 1 times m squared. In the denominator, we have n squared and then plus this when multiplied cancel. So we have simply m squared. Okay? Then plus 1. Get the LCD. What's the LCD? N squared plus m squared. So getting what? N squared minus m squared plus n squared plus m squared. Kalito naman n tsaka m. Bakit ba ito pang nagamit ng letter? All over n squared. Let's alphabetize. Starting with m. So m squared plus n squared. Remember, commutative property for addition holds, no? Okay, so what is the simplified form of the numerator? That is 2n squared all over yan, m squared plus n squared. But we know that from this right triangle, r squared is equal to what? M squared plus n squared. Is that correct, children?
Yes, sir.
So what is now the denominator?
R squared.
R what? R squared. Right? And this is equal to 2 times what? N over R, quantity squared. Is that correct, children?
Yes.
Yes, sir.
Yes.
What is N over R?
Cosine theta.
Then square it na theta. Kasi naka-square. And that's it. So we're now done. So proven. Using the definition of trigonometric function. Did you understand, guys? So you can use even trigonometric functions to prove trigonometric what? Identities. Let's now have the second one. Cosine theta all over 1 minus tangent theta minus tangent theta, then plus sine theta all over 1 minus cotangent theta. Let's work on the left side again. Because the left side is complicated, it's easier to work on that, making it the right side, okay? So this is our goal. Our goal is to make it the right side. So let's work on the left side. So we have to make the left side same with sine theta, cosine theta, making use of definitions of trigonometric functions. So let's start now. So this is equal to cosine theta. Wala tayong triangle na reference. Kopyahin natin yung triangle. What is the triangle before? Ito. Tandaan nyo ha. I will copy. I will make a triangle here. So this is the triangle. So this is theta, this is m, this is n. Is that correct? No? And this is r. Okay? So, from there, we now have, let me begin now here. What is cosine theta from the triangle, guys?
M over N.
That is n over what? Over r, no?
R.
N over r. All over 1
over B.
minus, what is tangent?
M over N.
Then plus sine theta.
M over R.
All over 1 minus,
N over M.
we have n over n.
M.
So when simplified, we multiply the numerator n over r by the reciprocal of the denominator. So the denominator is n minus m all over n. So it now becomes n over n minus m, right? Then plus, this denominator is what? M minus n all over n. So m over r times the reciprocal of m minus n all over m. So reciprocal is n over m minus n. Correct? Okay? So the denominator is actually not entirely different, no? So they differ only in sign. If I'm going to factor out negative in the denominator here, n minus m, I factor out the negative, so that becomes what? That becomes r, then what will happen, guys? If I factor out by the negative, so
R
this
times quantity
negative
M
of,
minus N.
magiging negative r, m minus n. O pares na ng denominator sa second term. So the second term is m squared all over, we have r, m minus n also. So since they have now the same denominators, so we can now combine the numerator. M squared minus n squared. So that is m squared minus n squared. Again, m squared minus n squared. All over, we have r, then m minus n. Okay? So that's it. What comes next? We can factor the numerator. What is the factored form? M plus n, m minus n. All over, what is the numerator? I mean denominator. R, then m minus n.
Minus n.
We can now cancel again. A common one. So ito. So what is left, which is to be written on the right?
M plus n over r.
M plus n all over r. We can split this, no? That is m over r, because we want to express it as trigonometric functions. So m over r is equal to what? Sine theta, no? Is that correct? M over
Yes.
r. What is n over r? N over r. That is cosine theta. We're now, no? So,
Yes.
done. So, proven. Yan, proven guilty. Yan, proven. Do you have any question, children of the Philippines?
None po.
Okay. So, let's now have co-functions. Relations among these. Tinanggal mo pala yung saksak. So we now have, let me move here. I will move it here. Yan. Ayan. Kanina. Functions among trigonometric, relationships among trigonometric functions. Let us consider this triangle. Okay, A and B here are what? Complementary angles. Again, what are A and B?
Complementary angles.
Oh, this is A and B, not RMB, ha? A.
Yes, sir.
What's the difference between A and B and RMB? Ha, guys? Is there a difference? Yan, A and B. A and B. Okay. So are what? They are complementary angles. Parang nag-slow motion. Paano nakikita yung sinusulat? Nag-slow motion siya. Parang lumulutang. Ba't kaya? Ano kaya problem? Yung problem PowerPoint? Yan. A and B are complementary angles. So let's determine the function values of A and function values of B. So we have, I think I wrote that already. Sine A is equal to A over C from that triangle. Remember this triangle? A, B, C. Ang opposite sa angle A is A. Adjacent is B. Hypotenuse is C. But to angle B, ang opposite ang B. Ang adjacent ang A. Hypotenuse sa C. I hope you remember that. So sine A is A over C. But that is also equal to cosine B. So, and cosine B is equal to cosine of 90 degrees minus A. Because B is what? Is a complementary function of what? A complementary angle of A. So cosine 90 minus A is B. So we say that sine A is equal to cosine B. Cosine A is equal to sine B. Tangent A is equal to cotangent B. Cotangent A is equal to tangent B. Secant A is equal to cosecant B. And cosecant A is equal to secant B, where A and B are complementary angles. So we say that sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. But be sure their angles are complementary angles. Cofunctions are also called complementary functions. Another relationships that we can get, we have what we call reciprocal functions, which you had experienced already, no? When we were determining trigonometric functions of an angle. Sine A is equal to A over C. Cosecant A is C over A. So they are reciprocals of each other, sine and cosecant. So we say sine A is equal to 1 over cosecant A. In the same way, cosine A is equal to 1 over secant A, because secant A is equal to C over B. Tangent A is equal to 1 over cotangent A. Cotangent A is 1 over tangent A. Secant A is equal to 1 over cosine A. And cosecant A is equal to 1 over sine A. So you have to memorize these relationships. And also the cofunction relationships. Okay? So, yeah. So we say that sine and cosecant are reciprocal functions. Cosine and secant are reciprocal functions. Tangent and cotangent are reciprocal functions. Look at the tangent and cotangent. Even in the cofunction and reciprocal, they are still the partners, no? But in cofunctions, the partners are sine and cosine, ha? But take note, the angles are complementary. While in reciprocal functions, to be reciprocal functions, be sure the angles are the same. Cosine A, reciprocal function, cosecant A. They must have the same angle. Okay? Yan. Let's have these exercises. So, complete the table. If I have sine 53 degrees, children of the Philippines, which later becomes children of China. Sana ano na lang, sa Europe. Wag lang sa Italy, maraming COVID. So we have sine. What is the cofunction, children?
Cosine 37.
Cosine na buhat.
37 degrees.
37.
7 degrees.
Okay, so we have 37 degrees. Are you sure pag inad 90 yan?
Yes po.
What about, cofunction muna para madaling mag-isip. Cofunction, sa cosine, anong cofunction? Sine. What's that? Anong angle? 9 degrees, 48 minutes. Then we have for tangent. What is the cofunction of tangent? Cotangent.
Cotangent.
Of, let's solve for the complement or for the complementary angle of x minus 30. X minus 30 when subtracted from 90. What's the answer? 0 minus x is negative x. Is that correct? 90 minus negative 30, positive 120. So we now have 120 degrees minus x. Okay, so that's the complement of x minus 30. When you add, that's 90. What about cotangent 28 degrees, 15 minutes?
Tangent.
Seconds. What's the cofunction?
Tangent.
Tangent. What's the angle? For 28 degrees, so that's around 60, 80, 60, 60 ano, 67, I know, 61 degrees yan. Then, may natira pa tayong 1 degree, no? Kasi 28 saka 61, ilan yon? 89, no? So, yung 1 degree, gawin nating 59 minutes plus 60 seconds 59 minutes. 59 minus 15. What's that? 44 minutes. Yung 60 seconds minus 3, so that is 57 seconds. That's now the angle. Okay? What about secant? What's the function, guys?
Cosecant.
Secant, cosecant. Kaya secant, cosecant. Cosecant, secant. Cosecant. But we have to take the complement of 2a plus 5. So 90 degrees minus 2a minus 5. What is that? 80 degrees minus 2a. Okay? What about cosecant? Secant na? And that is 90 degrees minus 150 degrees plus 3b.
Negative 60.
That is
Negative,
3b minus what?
negative 60.
Is it 60?
Yes po.
Okay. So that's it. Get it, guys?
Yes, sir.
Let's have the other, ito madali, kinokopya lang yung angle ng given, no? Kinokopya lang yung angle ng given. So, kakopya lang natin. So, sine, magiging ang reciprocal?
1 over cosine.
Of 53 degrees. This is what? Secant of 80 degrees, 12 minutes. What about tangent? Anong reciprocal?
Cotangent.
And then copy the angle. Cotangent, tangent. 61 degrees. Sorry. It's not. 28 degrees, 15 minutes, 3 seconds. Okay? Then we have secant. Anong sa secant? Anong sa secant? Cosine, no? 2a plus 5 degrees. Last, cosecant, sine of 150 degrees minus 3b. So, yeah. Okay now guys with that? My children. Yung iba yata kumakain na kayo ha. Iniisahan nyo kami ha. Yung iba kumakain na, hindi na nakikinig. Okay, let's proceed. Oh, we still have how many minutes? Trigonometric functions of special positive acute angles. So what do we mean by this? Trigonometric functions of 45 degrees, 30 degrees, and 60 degrees. These are positive acute angles that are special, meaning we can compute their function values exactly. Unlike other angles, for instance, if you have 28 degrees, you cannot find the exact trigonometric function value of such. You can only approximate, meaning tangent of, let's say, tangent of 21 degrees, so that is an irrational number. Unlike sine 45, sine 45 degrees is actually an irrational number also, but you can find that exact irrational number. Okay, you don't need to, you can find even not the approximate one. Unlike tangent 21 degrees, you can just approximate the decimal. So sine 45, from the triangle, so this is right triangle with acute angles 45 degrees, 45 degrees. From 45 to the other one is 45. If one leg is 1, this is also 1. If the other one leg is 20, this is also 20. If this is 1 million, this is also 1 million. You can assign arbitrarily a value to the leg. No? Let us assign 1. The best number to assign 1. But you can assign any number. Kung ito'y 10, ito'y 10 din. So if this is 1, this is 1, the hypotenuse is square root of 2. Because we square, then we add 2 square root of, from which we can now read the value. What is sine 45? Pwedeng dito, pwedeng sa taas. Kahit naman alin. Kasi kahit naman alin ang opposite, wala namang problema. No? So 1 over square root of 2. Hypotenuse, opposite over hypotenuse. So rationalize, that is square root of 2 over 2. When we multiply by square root of 2 over 2. So what about this one? Same, no? Kasi they are co-functions, so paras lang ang value. Pag co-functions, magkaparas ang value. O ito, tangent, opposite over adjacent, 1 over 1. That is equal to 1. Madali nang hanapin to. 1 din to. Ito, reciprocal, square root of 2. Kasi reciprocal ng 1 over square root of 2 is square root of 2. Reciprocal din, o kaya co-function sila, equals square root of 2. Okay? Sine 30. To derive the values of sine 30, cosine 30, and other functions of 30, we are going to use equilateral triangle. Equilateral triangle is a triangle having its interior angle equal to 60 degrees. Now, you can assign arbitrarily to the side, no? The length of the side. So, let's say if this is 2, this is also 2, and this side is also 2. If you assign a value to a side, 1 million, this is also 1 million, 1 million. If you assign 1, this is 1 also, this is 1. The best I think to assign is 2, because I'm going to divide this triangle into 2, so that half of the side is 1, 1. So this is equal to 1. I will take half of this triangle. If this is 60, 60, 60, half of the angle, when I draw the altitude, which is also the median, and which is also the perpendicular bisector, and also the angle bisector. Lahat sila, pare-paras at tawag dyan. I mean, they meet at a common line, no? Ayun yan, pag equilateral triangle. Ang median, altitude, perpendicular bisector, nagmi-meet, no? Sa isang line. So, okay, so this is 30, this is now 60. Kung ito ay 2, ito ay 1 na, kasi nati yan sa dalawa. So, 2 ang inassign ko. Then I can now solve for this leg, is square root of 3. So 4 squared minus 1 is squared, then square root of. What is sine 30? So from that top, dito ngayon ang basa, ito ngayon ang opposite. Itong side na to ang opposite ngayon. Yeah. Okay, opposite 1 over hypotenuse. Opposite, that is square root of 3 over hypotenuse. Tangent is opposite over adjacent. Then take the reciprocal. Take the reciprocal because they are reciprocal functions of each other. That is 2 over square root of 3. When rationalized, 2 is square root of 3 over 3. We multiply by square root of 3, we multiply by square root of 3. And then this is equal to what? Saan to equal? Reciprocal. Anong reciprocal? 3 over square root of 3. When rationalized, that is 3 is square root of 3 over 3, or simply is square root of 3. Okay? Or if you read it from the triangle, we just read it. Read na lang natin. So if you read it, you can have it 1 over square root of 3. Okay, that ends. Actually, there is still one trigonometric functions of what? 60 degrees. And I am giving you responsibility to answer this. I will be posting this in FB. Then you're going to answer for additional points. Okay, guys, that's it. If you don't have questions, it's already time because our table is already ready for lunch. Okay, do you have question, guys?
None, sir.
Okay, bye-bye. See
Thank you
you
po.
in the long vacation
Thank you,
time.
sir.
Okay, see you next week. I do not know, mag-announce na lang ako mag-meet tayo tomorrow ba o sa Friday kayo. So let's see. Sa inyong asynchronous. Kasi mawawalan tayo ng Monday. Stop recording.